So allow me to introduce you to 2017 number 4. This is a really beautiful problem. Wonderful one from the examiners here. We got a time t equals 0. Boiled potato is taken from a pot on a stove and left to cool in a kitchen. We got the temperature starting at 91 degrees Celsius at time t equals 0. Notice we have an initial value, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. My guess there is that the room does not fall below 27 degrees Celsius. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dh dt equals -1/4 h minus 27. Oh boy, there's our differential equation. We're in business, where h of t is measured in degrees Celsius and h of 0 is equal to 91. Oh yes, we caught that. It's like they're just telling us again, just in case we missed it. Thank you, Mr. AP Examiner. Letter A, write an equation for the tangent line. If you see those words and you have been sitting in this class, you should immediately know that you need the slope and you need a point. And good golly, we were given the point. We were yelled the point. They gave it to us twice. They gave it to us here, and they gave it to us up there. We have the point in two different places. So the point that we have is 0, 91. To get my slope, that's easy. We're trying to find the equation of at time t is equal to 3. We're trying to find the line tangent at, we're trying to approximate at t equals 3 by using the point at t is equal to 0. So we can get h prime of 0 or dh dt at t is equal to 0 simply by plugging into our differential equation. And our h, when t is equal to 0, our h is 91. So the slope of this line is -16. So our equation for our line is y minus 91 is equal to -16 times x minus 0. If we wanted to kind of button that up a little bit, we're actually talking about heat and time. So we could write this as, let's write it as y is equal to 91 minus 16 times the amount of time that's passed. That's the temperature of the potato. So our temperature at time is equal to 3, at t is equal to 3. Our approximate temperature is approximately 91 minus 16 times 3. That's 43 degrees Celsius. So approximately 43 degrees Celsius. Boom. We got the point. Boom. We got a slope. And then we did an approximation. Guess how many points that is? That is 3 points for you right there, just by finding the equation of a tangent line and then plugging in to approximate. Part B, I think you can see it coming. Part B asks you to tell me whether that estimate is an underestimate or an overestimate of the internal temperature at t equals 3. We need to know about the concavity of this thing, so we have to take the second derivative. We need to go get the second derivative. We need to find d2h dt. When I take the derivative of this thing, it's -1/4 dh dt. That's the derivative of this thing. That's the derivative of this thing. If it's helpful for you, we can rewrite dh dt as -1/4 h plus 27/4. And when I take the derivative of that, when I get the second derivative, it's going to be -1/4 dh dt. There's a little implicit differentiation, and the 27/4 is just going to go away. And now we're in business. Okay? So there's our second derivative. But guess what? I know what dh dt is. I have seen dh dt. It has spoken to me. I know dh dt. dh dt is exactly what we were given up above. It's the -1/4 times the h minus 27. And what that tells me is that the second derivative is always going to be positive. Why is it always going to be positive? Because remember, we were told up above that our temperature is always greater than 27. So this thing is always greater than 0. Therefore, the graph is concave up, and the estimate is an underestimate. Concave up means that the tangent line that we use to make the estimate is below the curve. The tangent line is below the curve. It's an underestimate. That was one more point for you, bringing your total to 4 points. Finally, letter C. It gives me a new differential equation. It says for t is less than 10, an alternate model for the internal temperature at time t minutes is the function g. So this is a new dg dt is a new differential equation. They're just throwing this one out there. They're saying, forget about that dh dt, let's use dg dt, where g of t is measured in degrees Celsius and g of 0 is equal to 91. So still the same initial condition. Find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t is equal to 3? So we're going to find an expression, and then we're going to try to plug in. So I'm going to rewrite this thing down here. I apologize. I got to add a page. Just please be, oh gosh, be a little patient with me. This newfangled technology is getting to me. Sorry. All right, let's add a page here. And we are going to use, from part C, we are going to use the fact that dg dt, that thing that we were just given, I'm sorry, I got to go back and look at it. dg dt is equal to negative g minus 27 to the 2/3. Now, if at this point this is not obvious, that's okay, but let's make it obvious. We are going to separate, and then we are going to integrate. Separate, and then integrate. I don't know why they have you do this other equation as a separate and integrate. I think the first one maybe just was a little bit meaner than they wanted to be. Or maybe the other way. I don't know, whatever way is easier. I don't know what's easier. But we are going to separate the dt's and the g's and the dg's. I'm going to bring this negative over to the other side just to make my life slightly easier. Again, this is what we were doing in class today. This is what we were doing. These can get kind of messy, and there's more than one way to kind of go about doing these. But we are going to separate. And then I want to show them that I know that once I separate, I am going to integrate. I'm going to separate, and then I'm going to integrate. When I integrate this g minus 27 to the 2/3, I can think about that. I'm going to write it off to the side here. This is g minus 27 to the negative 2/3. So we're going to add 1 and then divide by that value. So this becomes 3 times g minus 27 to the 1/3. Now what am I going to do? Now that I have it at this point, I'm going to solve for C. How am I going to solve for C? I'm going to plug in the value that we were given. We were told that when G is equal to 91, our T value is 0. 91 minus 27 is 64. 64 to the 1/3 power is 4. 4 times 3 is 12. So our C is equal to 12. Now we can go ahead and we can solve for our G. Now if you didn't solve for the G in this problem, technically I don't think they could take off points for you. I'd have to go back up and read the prompt, but I don't want to go away right now. But I think it's good habit to go ahead and solve for the G. This is going to be 12 minus T divided by 3. We're going to put both sides to the 3rd power, and then we're going to add 27. That's what my G of T is equal to. And we did that between 0 and 10. When T is less than 10, that's what our G of T is equal to. The last thing it asked, and this was really easy to miss. I know I had a few kids who were frustrated because they didn't realize they got this problem. They were really excited. and they didn't realize that they were supposed to actually estimate at t is equal to 3. The last piece of this is just to do g of 3, which is 12 minus 3 over 3 to the third plus 27. So I'm just taking, all I'm doing here is just taking 3 and I'm plugging it in for the t. 12 minus 3 is 9, divided by 3 is 3, 3 to the third is 27, plus 27 is 54 degrees Celsius, and there are 5 more points. And that's an awesome question by the AP examiners. Well done, College Board. Well done.